So if you're joining me right now and you saw the title come up, it's wrong. I don't know why it's wrong, but it's wrong. So just so you know, what we're actually doing today is a short session, Monday session. As promised previously, I am giving a quick review of this book, Refactoring Databases. It's a retro book for technology at this point, published in 2006. Um, Yep. So some of the stuff is a little old-ish, but it's still very relevant in certain kinds of ways, especially for relational databases, especially where you have multiple applications using a single database and other scenarios like that. So what we're going to talk about today in relation to that is a couple things. Single database, single application database, multi-application database, and then we're going to get into code smells a little bit. The idea behind each of these, single application database, is basically like you got a database that's only used by a single application, so that if the application is doing one thing, the database has a matching set of tables or views or stored procedures or something, some element, some trigger or whatever that matches the applications, a database application. But then in other scenarios, you have multiple applications, especially like in an enterprise environment where you might have enterprise resource planning applications where there's actually multiple applications and they all work against the same database. A similar way to think of this, even though it's a little bit obfuscated, is Salesforce. Prime example of where a lot of applications used a singular database, a singular CRM database, customer relationship management database. So those scenarios come up pretty regularly in enterprise. When you have an application, like let's say you're a startup called Fluber and you do ride sharing, you may have a singular database or a singular data store in which you work with. So in that situation, you're talking about one application using one database. That's a little bit of a weird example because in startup world, you often have a data store, which is made up of many databases. So that's where this book kind of breaks down, because you just simply don't have a one-to-one relationship in most scenarios these days. You may have many disparate types of scenarios come up. A common thing, though, no matter what you're doing, it's still very, very common, though, no matter how many different disparate solutions come up, is you still routinely have a database built for a solution. A lot of demos that you see online, like to-do applications. A database, the to-do app is built onto that database. Pretty straightforward, right? It provides a great starting point. However, the world gets more complicated once you get past that. So let's take a look at some of these things. Let's build out some tables to talk about situations you run into when you're building a single application database, but more specifically, like what happens when you move past that and you get to the multi-application database. So over here, there we go. We have here single application database. This would include things like, let's say, React interface attached to a singular database. Or let's say a Windows app connects to a single database. In this world, though, we might have something, let's say, especially like, let's say in context of Hasura. Hasura provides a great interface. Yes, I do work for them, but big shout out, because the product is awesome when it comes to pulling in remote schemas. So you might have the Hasura GraphQL interface and the API that it provides connected to Postgres or MySQL, and those two databases have different tables and columns and whatnot. But then you may pull in a Gatsby GraphQL API interface into the remote schemas feature and bring all of those together, so that when you're dealing with the API, you're dealing with the Hasura API instead of 3 different APIs or whatnot. So that's a prime example where you may actually have multiple databases, but a singular API is where you access that database from. So interface attached to multiple databases through a singular API. Okay, that's single application, single database from an overall architectural point of view. More realistically, though, you have multiple applications attached to multiple databases or data stores. Okay. What would you call, like, they could be connected to Kafka. Prime example, Kafka is not particularly a database, is it? It might store some data in some state or managed situation, but it's not a database in a traditional sense. Or you might have Elasticsearch, not a database, but very much can trick you into thinking it's a database, and you might use it specifically as a database, but it's primarily a search data store, right? You search through that content. That's its core focus. Then you have other things too, like a time series database is a database, very specific use case, et cetera. But all those may be independent or they may be wrapped to an API. If you think of your API as your application though, or one of the applications, it may even fit into the single application database concept, right? Single application using, oops, I should clarify that, using a singular database. Oops. Can't spell again, as always. So that's some of the examples there. Let's keep this one here. So multiple interfaces, such as a React interface, plus a CLI attaches to a Postgres DB plus API endpoints plus time. Okay, so that's an example. Now, when you have these types of scenarios come up, this is where things get tricky. Let's talk about that for a second. What do we have? Yep. All right, so we'll do. I can do this. Oh no, whoops. We need to go to migrations. There we go. Oh, my metadata is in a weird state. Oh yeah, let's delete all this. I don't want that metadata. We'll go back over here in data. So an existing table we have the table with the three body problem table. Let's work under the 3-body problem table. That almost kind of makes sense for what we're talking about. Let's say in one database you have the users table. It has an ID, right? Gen. Name. And we'll go with text. And then one in there. Make it unique. And then stamp. This will be a date. And we'll do now. There we go. Okay. And primary key. Let's create that table. Now let's say in another table, in another database, there's another table, and we need to synchronize that. So we pulled that table into our database. We're going to call that table users from another database. Okay. Now it has name, and we'll call them text. This, we're going to say they're unique names. Now let's make it more complicated. Let's say there's not unique names, but then let's say there's email, text. That's unique, has to be unique. And then what do we got? We got something else. We'll do another stamp. Now, unique. And then details. Let's do this in the middle. All right. Primary key is going to be not name, but email. Add that table. And then let's say we have another system. We'll call it user details. Okay. So we'll have email. Yep, unique. And then we'll have stamp, date, details, JSON, B, sure. Sounds groovy. And then let's email as primary key. Now over in users, what was it? What do we have? We have ID, name, and stamp. All right. So if we look at these three tables, we look at this data, now we bring these together and we need to refactor these three into a singular one so it can be used as a system of record across all of our applications. Let's say one application pulls in the user details, another API sets the user from another database, that's an import, right? And then users is the core table that we have that we've been using. So one of the first steps that we do, let's see, look at users from another database. And we're going to only be able to do part of this so far. I'm going to put some test data in here. We'll maybe mess with it at a later time. But I'm just looking. Yeah, I used the wrong thing here. Well, we'll tweak it later and mess with it. But the idea is you have these three tables and you need to bring them together. So really what you want to do here, one of the refactoring options is to, since we have pretty clean table structures, not a lot of peripheral data that has nulls or whatever. So like if you look here, we don't allow nulls in any of this. Same here for these tables, right? So because of that, we can effectively begin to merge all of these tables. So let's say we have name, or not let's say, but we have name, email, and stamp. So in here, what I'm thinking is the systems would most likely bring in these and they'd have the same name, right? And probably a stamp that was similar because the databases are getting the data about the same time during the registration process of the user, let's say. So that's how we would have to pull those in and make sure that the stamp, the date stamp is within plus minus 5 minutes, 10 minutes, something like that to ensure so that if we run into a name conflict, right, we don't have an actual conflict when it's imported in. So here we have email and stamp. Let's go over here and we'll add a column, we'll do email. Now see, this is additive, right? I'm going to set it as nullable because we don't know what we are or aren't going to get from a table merge, right? So we'll add that. And then, let's see, we'll add another one. And just to keep these together, we'll do email stamp. And that's going to be nullable too. Save that. And then over here in user details, we'll want to merge this in too. And we have email, stamp, and details. So email is unique here and email is unique in the other one. So based on that, really all we need to do is add details to this and we'll have all the data. And maybe the details timestamp, right? Because that could be disparate because the user might change the details after the fact instead of right during the registration process. It'd be something they could do later. So let's add details. We got nullable. And then details stamp. Like that. So now that table is refactored in a way where we can now bring data from the other two tables in based on a flow. So we get users, right? Or we have users, and then we would bring in the users from another database through an import process. Once we do that, we can run a second process that would then go through and grab any user details that are available. The user details being something that could be updated post facto or post the initial merging of the data. So bringing those two together gives us the ability to link to that third one. So that's one idea on how to do refactorings when you're going from the complexity of a single app using a single database to multiple apps using a database or multiple databases. And this is bringing it into a singular system of record where the user would be one table that you could use as a system of record, but it would be collecting data from other tables from other databases. So that's one way this can be done. Of course, as is probably obvious in this example, you have different things in there that you need to go through and write automation code around. So it's not like you just click and all the integrations and merges start happening. Sometimes there's ETL processing tools and things like that you can use to help with this. But overall, this is your core refactor. There's 3 tables, and users is refactored to work with those other 2. So I'm going to bounce out of here, close this down. And of course, in good old migrations here, if we look at that, you can see a whole bunch of these changes were made for the 3 body problem. So there's up, down, the alter table, etc. So all those are in there, and the migration can then be run, and you can do the refactor or not do the refactor, bump up to a version, back to a version, however you need to do that for the overall process. Okay, so the next thing, let's go through some of these. I'm going to talk through some of these wonderful anti-patterns. Now, anti-patterns are pretty fun. Those are the situations where you run into like using 5 languages to do one thing because of some weird hacky reason, whatever it might be. But some of the ones that are mentioned in the book, I just wanted to cover some of these. These go back to ideas built on, it mentions Fowler in 1997, so 1,000 years ago in prehistory, introduced a concept of a code smell. That's true, he did. But a code smell is basically an anti-pattern, a way of doing something that isn't particularly the best way to do it. It may not always be the worst way to do it, but it isn't in a particular situation the best way to do something. And some are axiomatic, i.e. always true, that they are the worst way to do things. So there's a varying degree on each one of these things. As you look through this stuff, you should take that into account. But let's see, one of the first ones, let's cover it. Oh yeah, these are glorious. Multi-purpose columns. So let's say you have a column, you put text in it, okay? It reads as if a column is being used for several purposes, it is likely that the extra code exists to ensure that the source data is being used the right way, often by checking the values of one or more other columns. An example is a column used to store either someone's birth date if he or she is a customer, or the start date if that person is an employee. Worse yet, you're likely constrained in the functionality that you can now support. For example, how would you store the birth date of an employee? That's an example, just like those columns that we added. Let's say another one had the email and then other details. So how do you merge the details? Let's say it's both JSON, right? Do you just have, like, how do you deal with that? You've got 2 columns called details from 2 different tables. And if you're trying to bring those in, you'd have to determine how to merge that data. Would you just append it to the previous data that you had? Would you append it, like how? How would you do a diff on it? Would you literally pull in, look at the JSON object, and then do a diff on the JSON object? That's a feasible option there. In the example given, and I've seen this a lot in different enterprises, where you have a field and it's a start date, but then all of a sudden you realize some people, they started in like, I don't know, 1982. It's like 1982, that was such a long time ago to start. And then you look, you're like, well, the company's only 5 years old. Oh yeah, 1982, that's their birth date. So sometimes the person's date field is their start date. Sometimes it is their birth date. Now, how do you determine that? A lot of the time in databases, the data will be so crazy and corrupt, and they're not corrupt, but just like kind of weird and obfuscated about how it works. You look through other columns, and a lot of the time you'll find a differentiator there where it'll designate what that multi-purpose column is set as. Is it the start date or is it their birthday date? In other scenarios, a lot of the time with like that as an example, you just got to throw it away. You just got to trash that shit. It's unusable in a reliable manner. So just get rid of it. Let's see here. There's, another one is this is an anti-pattern. I don't know if it's in the book. It's one that I was just reading about a little earlier today, where people put a hierarchy in a table. Okay, and what I mean by that is they build a recursive hierarchy in a table, but again, just like the multi-purpose column, the hierarchy in the column field where it dictates the hierarchy or wherever it would go within the hierarchy, it's like depth, and then ordering is usually like 2 fields you'd have, and then that can recursively put it into like a bullet list or some type of grid or something like that, or it might have multiple depths, so you could have another dimension to it, and it would relate to like multiple tree views or something like that. As you break open something, it can get quite complicated. And then some people will build out tables where you have all of those columns in one table, or you might have a column and it describes the depth based on other characteristics. But that can be very confusing, not just from the data storage perspective, but also how do you process that post facto? You're literally setting up not just the structure hierarchy of the data, but the structure hierarchy of how it needs to be displayed or referred in other layers outside of the database. So a lot of the time, the idea is to prevent that from being a problem, you want to have a one-to-one to the actual data that the tree view or whatever it is going to display, but then have the hierarchy of that built up in a diff table that's specific just to the hierarchical structure of the way the data is stored or referenced or organized, something like that. So that's one that can get extra tricky. Also, just the notion that the recursive nature of it needs to be intuitive in some way to be able to write code around it. Every programmer isn't going to be able to look at that and determine that. So either it needs to be stored in documentation, or some other peripheral piece around that data needs to very specifically outline what the hell is going on with that data. So that can be an anti-pattern. It can be the way you need to do it, but it can also very much be an anti-pattern. So let's hear. Another one. Now, this one is an anti-pattern sometimes. Mentions tables with too many columns. Let's say you're using something like Honeycomb, though, for tracking what's going on with your app, getting insight into it and introspecting against your application. The high cardinality of Honeycomb is part and parcel of the inherent system. Like, you're using it for that. That table structure in there has many columns. It's supposed to. That's fine. That's its purpose. It's enhanced and built around that premise. In a lot of relational databases, and even in databases, especially even more so, I would argue, like Apache Cassandra, you don't want to have a gazillion columns in your table, okay, for many different reasons. Sometimes for performance reasons, sometimes for organizational reasons, but also as you increase your column count, you're more likely to do things like have to leave a lot of the columns empty or null, and then you end up with the paradigm of, are you dealing with empty or null or something like that? The best way to generally structure tables is to put, and this is just like with applications, just like a lot of things, keep them as simple as possible and keep them as minimal as possible. Don't dump a bunch of columns in there unless you absolutely have to or absolutely need to. It's often even a good idea to have like a one-to-one between a table and a table. And if you, for instance, initially don't have that one-to-one, but you've created a table and you have a bunch of columns, and then you notice, oh crud, I have, no pun intended there, I have a bunch of columns that have data in the rows that are ending up empty. I don't want those columns to be empty. I want the data to fill up the tables appropriately and not have a bunch of arbitrary emptiness, because that's taking up space, but it's not really doing anything for me. So what you can do is you can go one-to-one, and where it's just, you just add data sometimes for certain columns, put those columns in a one-to-one relationship in a different table. And then that way, only when you add that data will that table even have the data. So you're not storing emptiness against a core primary key or something like that, or a primary user in the user's database, or entity, whatever the entity is. That way you minimize the amount of storage used to store empty data. And you just keep it more structured in a logical sense, because then when you're dealing with a table, you're dealing with a table that has data. You're not dealing with a lot of scenarios with empty, where you're doing empty checks or null checks or whatever, all that arbitrary stuff. So that's another example. Overall, though, there are a number of things that are listed in Yay book for refactoring around the anti-patterns and stuff like that. We'll talk more about those in a future session. Like I was saying, this is just a short 30-minute blurb today. And future context, we're going to be going through the rest of the chapters, just to give a shout out to that. So every Monday at 3 p.m., I'm going to be tackling this book until we're completely done with the book. Basically doing a chapter a day, 30-minute chunks. Today was chapter 2, went through a little bit of the modeling, a little bit of the ideas of anti-patterns and around single and multiple applications against a database or databases, and just discussed how some of the ideas here are a little antiquated in the sense of how we use databases today and how many more database options we have to use. So every Monday, 3 p.m., I'll be talking about databases. Hope you join me. If you have any questions, thoughts, or otherwise, feel free to dive in, throw your 2 cents in, ask me anything. I have answers, even if the answer is look it up on Google. So on that note, peace out, everybody. Happy thrashing code. I always go look in StreamYard for the outro, and there's never an outro. I forget that there's not an outro. So with the no outro, there is no outro. So I'm providing an outro by just talking. Anyway, subscribe, follow, link, etc., and I will catch y'all next time. Cheerio.